Desai,
yes, sir. Sure.
go ahead.
Morning.
Should I start, sir?
Yes,
Yeah,
sir.
sure.
Yes. Good morning, esteemed dignitaries, resource persons, faculty members, and dear participants. It is with immense pleasure and gratitude that I, Husna Desai, Faculty and Language Lab Coordinator of English Department, extend a warm welcome to each one of you to this one-day national webinar organized by the Department of Statistics at Bangaramma Sajjan Arts, Commerce and Science College for Women, Vijayapur. This event is proudly presented in collaboration with Karnataka State Statistic Association and our Alumni Association. This webinar is an embodiment of our collective enthusiasm to explore a new dimension of knowledge in the field of statistics. We are truly privileged to have a distinguished panel of resource persons who will be sharing their expertise with us today. To begin this enriching journey, I would now like to invite Dr. A.T. Srinivas, the head of the Department of Statistics, to give the welcome address. Sir, please. Sir, Srinivas, sir, over to you, sir.
Thank you, madam. Okay, thank you, madam. Good morning to everyone, team members, dear participants, research scholars, and my dear students. It is with a great pleasure and sense of privilege that I, Dr. Srinivas A.T., head of the Department of Statistics, BLDEA Association, Srimati Bangaramma Sajjan, Arts, Commerce, and Science College for Women, Vijayapur. I would like welcome each one of you for today's national webinar on essential skills and sampling keys to success for statistics, organized under IQAC by the Department of Statistics in collaboration with Karnataka State Statistics Association and Alumni Association of our college. I extend my heartfelt welcome to resource person Professor TPM Pakkala, Adjunct Professor, Mangalore University, Mangalore, on behalf of our institution, Karnataka State Statistics Association and the department, I would like welcome you, sir.
Okay, thank you.
I also Dr. Gangaboraya Andanaya, Professor Emeritus of Statistics and Research Aide, Dayanand Sagar College of Dental Science, Bangalore. On behalf of our institution and Karnataka State Statistics Association, beloved principal, Dr. Tammanna Y, in this occasion. I extend my heartfelt welcome to our organizing committee, everyone to actively engage, ask questions, and make the most of this learning opportunity. Let us together explore the world of statistics, and I am delighted to say that near about more than 6 success. Thank you for giving an opportunity. Thank you, one and all.
Thank you, Dr. Srinivas, sir, for your gracious welcome.
Thank you, sir.
Now, I would like to invite Dr. S.R. Gani, Joint Secretary of Karnataka State Statistic Association, Dharwad, to welcome and introduce our first speaker, Professor T.P.M. Pakala, Adjunct Professor at Mangalore University, Mangalore, Karnataka. Sir, please.
Thank you, madam. Thank you, madam. I welcome once again all the participants to this one-day national webinar. I am very happy to introduce the today's speaker, Professor T.P.M. Pakkal. Dr. T.P.M. Pakkal is currently adjunct professor of statistics, Mangalore University, Mangalore. He started his teaching career in 1979. From March 1982, he was serving in the postgraduate Department of Statistics, Mangalore University, Mangalore, until his retirement in the year 2017. Afterwards, he served as a professor in Justice K.S. Hegde Institute of Management, Nitte, Karnataka for 2 years. Also, currently he is the chairman of PG and UG Board of Studies in Statistics, Mangalore University, Mangalore. He is currently president of Karnataka State Statistics Association, which is in the process of the registration. He has been awarded a postdoctoral research award from University of New Brunswick, Canada, for 2 years during the year 1996 to 1998. During this period, he carried out a research and teaching in the university. He is also a recipient of Commonwealth Fellowship for Postdoctoral Research, and he carried out research at University of Exeter, England, for 1 year during October 2001 to September 2002. He has more than 65 research publications in Scopus Index, reputed journals, international journals. Almost all his articles appeared in the scale support ABDC journal list. That is A plus, A, B, and C. He has more than 150 seminar presentations, invited talks, and general academic talks. Apart from India, he has presented research papers in conference abroad held at Hungary, Canada, England, Australia, and South Africa. He chaired several sessions at international conferences on operation research and statistics. He was acting vice chancellor of Mangalore University, Mangalore, for a very short period. He was a dean faculty of science and technology, Mangalore University. He was a member of a syndicate and the academic council of Mangalore University. He was also a chief of University Employment Information and Guidance Bureau, Mangalore University. He was a professor. He was a president of Association of British Scholars, Mangaluru chapter. He was vice president of Mangla Alumni Association of Mangalore University. He was president of Vishwamangala Education Society, which runs KG primary, high schools, and pre-university college. He was the chairman of Department of Statistics, Mangalore University, Mangalore, for several years. His area of research interests are inventory modeling, stochastic modeling, data science, research methodology, statistical analysis of finance, and has a good knowledge of computer programming. He has published research articles in top international journals with high impact factors in statistics and operation research. Some of the journals he published in Decision Science, European Journal of Operation Research, Analysis of Research, Computer and Operation Research, International Journal of Production Economics, Journal of Operation Research Society UK, Journal of Indian Society for Probability and Statistics, Applied Mathematical Modeling, etc. He was nominated for the Dr. Alan Stark Excellence in Teaching Award for 1998 for the best teaching at University of New Brunswick, Canada. He has been a chairman and member of several committees constituted by Mangalore University. He was very instrumental in introducing a recent CBCS regulations for the postgraduate program of Mangalore University, Mangalore. With this brief introduction, once again, I will present as today the webinar speaker, Professor TPM Pakkar. Over to you, madam. Thank you.
Thank you, Gani sir, for your incredible introduction. Now, I would like to take this privilege to invite Dr. TPM Pakal sir to deliver his lecture. Over to you, sir. Sir, please.
Okay. Thank you. Good morning, all of you. I'm very happy that we have a very good audience. Let me, before starting, let Professor Ganga Boraya and Dr. Y. Tammanna and Dr. Srinivas and so many others, Dr. Gani and others, let me, and research scholars, students, and many participants. We're happy that you're all interested in statistics, where statistics is a very good subject with a lot of scope and needs much encouragement. Basically, I prepared this for degree students because the major students or participants are degree students, but this is very general talk, not so much technical, but very much needed for the students who are seeking for their career with the statistics background. Mostly I will be speaking in English. Maybe here and there I may pick up some Kannada to make them understand, but mostly I'll be speaking in English. Okay, let me present my slide. One minute. Data science. Okay.
Sir, just click on present, sir.
Yeah, I'm just searching the. I got it.
Okay, fine, sir.
It's going to appear, I suppose.
Still not, sir.
No, it's coming up.
Okay, fine.
I have clicked it, but it will take some time. Okay, meantime, let me start the discussion. So mainly our students or statisticians deal with data. Say like doctors deal with the body of a person, and okay, here it has come, I suppose, right?
Yes, sir.
Yes,
It's
sir.
visible, sir.
You could see that. Okay, that's good. So data is a backbone of statistics. Say, for example, any say any other professionals, their main work, say for IT, they mainly deal with the computers, whereas we deal with the data and then whatever is necessary, maybe computers or any tools for data analysis. So data is very important aspect. Let me, yeah. Now, in a data, when I'm talking about data, India's digital economy is experiencing rapid growth, driven by expanding internet access, improved digital infrastructure, and increasing digital adoption across various industries. Now, everywhere we can see that most of the things are digital. Digital means maybe it could be mobile or even computers. The data is in electronic form. And when I say data, the data need not be only numbers. It can be categorical data. It can be names of some items, names of the persons, names of the or age or gender. So many things. So it may be like when we say about scales, nominal data, or it could be ordinal data, or it could be integral or ratio scale. Any of these numbers. So normally. People think that when we are talking about statistics, deals with numbers, but we also deal with the other data forms. So any of the data type, ultimately it will be converted to numbers, and then we are going to analyze. So when in the present era, where it is a digital era, say for example, Indian National Statistical System is one of the largest and most intricate statistical operations in the world. It's really a very large scale, and they have lots of digital data. As a government or private, entire nation is considered, we have a large data compared to so many other countries. So dealing with this type of data is one is a requirement, one of the most requirements. So with India's rich digital footprint, rapid technological advancement, because these days it is moving up, and economy is also moving up. Expectation from the country's statistical system is really evolving, and it is needed, and people are looking for this type of rapid growth in the digital. When there is so much of digital information available, and how to deal with that. So as I said earlier, statisticians are the right persons to deal with data. Say computer scientists also deal with data, but it's more mechanical than understanding data. So whereas statisticians' primary work is to understand the pulse of the data, all the data, how it is, what is the property of the data, what is the nature of the data, and only by understanding data, then we go for computations. So that is what is the requirement of statisticians. So now, we have data-driven decisions contribute to very large scale in India. So a survey found that around 80% of Indian business leaders view data as essential for decision making in their organizations, highlighting the rising importance of data. 86% of the data-driven organizations in India, say for example, Infosys or Wipro or TCS, all these things are data-driven organizations, and they are planning to increase and sustain their investment in data skills, emphasizing its value and driving business success. If they wanted to get business success, they have to understand how to deal with the data, how to analyze this data. It requires a skill. So that type of skill is required for dealing with data. So when we talk about statistics, it is a uh, it is numbers that we are dealing with, and students are the one who is going for the career of such a work. They need to understand what are the extra things they need to learn apart from what they have studied, what they are going to study in their BSc course or even MSc course is the same thing. Okay, now one of the problems I have is can I? I got it. I got solved it. Okay. Now statisticians have to develop skills to handle. As I said, the statisticians are dealing with data. In order to deal with data, appropriate persons are statisticians. As I said earlier, statisticians who is understanding data from the beginning, including descriptive or any inferential part or any of these things. Whatever they study in BSc, everything is related to data, and understanding this is required. But then something more is also required, because when they go for job, most of the cases what happens is what they have studied may not exactly directly applicable there. They encounter with the real problems, they encounter with the unknown unseen problems, then they need to understand how this can be dealt with. So big data sets are the common things now, and data sets are not very simple, they're not very complex. When it is the digital data coming up, we may not have structured data. Structured means, a data is given normally in the classroom. Say if it is BSc classroom, then they are given some data which is in the tabular form, or a row, or at least either just raw data without any rows and columns, maybe just one row, or in a rows and column tabular form. So this is what the form is, which is called as a structured data. But in real life, when they go for job, they come across data which are complex in nature, and they come across huge data, because nowadays any data can be taken. Say for example, even if you take mobile itself, the number of photos that is accumulated need to be seen, that some of the photos to be deleted, otherwise the size of the memory is overloaded. So that's a type of data where it is expands even in a small cases. So data is really big, and when really statisticians are working on a problem, the problem is not very simple. They have to look into solving a typical type of problems which is related to data, may not be a very simple data. They are coming in a digital form, means it will be big data. So the big data has come up after the introduction of computers. When computer collects the data, it is very huge. Whereas even when we are collecting data, say for example, census data is very large data, but this is now normally nowadays, even if it is digitalized, but earlier it's a manual collection of the data. Maybe data is very huge, but then it is a man-made or prepared by human intervention. So that is a serially selected by persons. So it will not be so big as compared to the computers, computer collected data or digital data, which is called as the digital data. Then so this is the scenario students are going to face when they are going for career. So that is why I'm just explaining these things, how the changes are going to come up. So they may require more scientifically looking into the data, because normally whatever they have studied in BSc is a foundation to deal with the data, but only these things cannot be sufficient when they go for solving or analyzing a data, because when they look at the data and matching with the questions, and then they may have to do something more, and there are more advanced techniques available which can be easily applied, and understanding such methods, scientific methods or statistical methods, newer methods, which will have wider applications, are needed. And this may require using of software. People may use statisticians don't use SPSS, but they use SPSS for the purpose of others, like solving social science data or commerce management data. So SPSS is also used. Much more than that, when it comes to solving a real problem, they may have to write sometimes coding. Coding means writing a program. So even that may be a requirement in the later stages. And these things are not very difficult. Say coding, learning these things are nowadays very simple, but it is a requirement for statistician. I would say that if not BSc, afterwards they may learn. Otherwise, after joining for job also they will learn. But if they are already learned about computer programming or coding, some simple data, maybe using very simple programs like um, R program is also simple, not so difficult. So such exposure, if they have, certainly it is better. Or else, instead of SP or things like SPSS or Minitab, or for the place of SPSS nowadays, Jamovi has come up, and Jamovi is equivalent to SPSS, so they can quickly solve even long problems using this type of software. Now, statistician's challenge. What is a statistician challenge? Already I mentioned some of them, but let us see. They encounter only not one type of problem. The problem may come from any area. See, in some other area, they may get very restricted to their discipline. But here, what happens is our discipline is an application in so many other fields. So the area may be different. Understanding different area is also required. Not that we have to learn right now, but we should have a readiness to face different type of applications, because data, it is not only when we are solving the data, it may be just simply data analysis or getting some number, applying some statistical rule, but having a knowledge of why this is used, how it can be applied, needs some more understanding of different area, and ability to learn applications of theory they have learned. See, they learn in especially BSc. Let's talk about BSc. When they are studying BSc, they will learn point estimation, interval estimation, or t-test, and analysis of variance. Excuse me. The various this type of theory they learn, but they should know when to use what, for which type of data these are sufficient or these are not enough. Also, limitations. They need to understand applications and limitations of these various types of statistical methods. And able to adopt and learn, face modern analytics. What happens is, suppose we give some solutions, that solutions which are known to us, so we will give that. But better to see whether our analysis can be updated. can we give some better solutions? Looking at the stage of implementation, we can again revisit our method and their applications, how it is going to work, and then, if possible, update the method or change the method or improve the method. This is this is what can help these in their career. And there is one problem is that nowadays most of them are statisticians. Most of them means most of the people who analyze data are calling themselves as I am statistician. But actually, what happens is, yeah. But what happens is, when these people are solving the problem, they will use, say, for example, suppose someone is using SPSS or equivalent to that is Jamovi. There is for any data, any method can be used. So they have some standards. They know certain assumptions. For when these assumptions follow, they will use this. Certain specific methods. But statisticians learn about the data more deeply than the other persons. Statisticians know the pulse of the data. So even looking at the data, they can able to say what type of relation they hold. Say, for example, regression. Normally, statistician may not go for simple regression immediately or linear regression immediately. They will look into the data, and whichever is appropriate, they will suggest. Whereas non-statisticians, who themselves claim as a statistician, may apply certain inferior method compared to statisticians who have studied more methods. So I'm not saying that they may not able to do the job, but statisticians are really better in these fields where these can be the results can be improved further. But what happens is, the problem is that nowadays the problem is that less number of statisticians are available, and less number of statisticians are not able to cope up with the present method of data analysis. So present data analysis requires application of computers, application of softwares, application of computer programs. So if present students, when they are going for job, these type of inclination, they should have it in their mind. They may not know about it. They may not understand what is coding right now, but it is not difficult. Say, the process of learning is not so difficult nowadays. People can learn without even teachers. Nowadays, in the internet, you will get so many help. So much of that can be learned on their own. So these challenges are there for statisticians before taking up a job, or even after taking up a job. Now, let me talk about the skills, main skills, what is required for statisticians, especially either they are undergraduate or even for postgraduates. They need to have three main type of skills. One is a technical skill. Technical skill means whatever they have studied. ಅವ್ರು ಕಲಿತ ಸಬ್ಜೆಕ್ಟನ್ನೇ ಸರಿಯಾಗಿ ಕಲ್ತ್ಕೊಂಡ್ರೆ, ಅಂದರೆ ಅದರ ತಿರುಳು ಎಲ್ಲ ಗೊತ್ತಿರಬೇಕು. ಅದು ಹೇಗೆ ಯಾವಾಗ ಅಪ್ಲೈ ಮಾಡೋದು. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅವ್ರು ಕಲ್ತಿರ್ತಾರೆ, ಪ್ರೊಬ್ಯಾಬಿಲಿಟಿ ಕಲ್ತಿರ್ತಾರೆ, ಎಸ್ಟಿಮೇಷನ್, ಇನ್ಫರೆನ್ಸ್. ಇದರ ನಾಲೆಜ್ ಮಾತ್ರ ಅಲ್ಲ, ಅದು ಹೇಗೆ ಯೂಸ್ ಮಾಡೋದು, ಯಾವಾಗ ಯೂಸ್ ಮಾಡೋದು, ಯಾಕೆ ಅದು ಬಂತು, ಇಂಥದ್ದೆಲ್ಲ ಗೊತ್ತಿದ್ರೆ that will help. And second is a domain expertise. I'll explain these things in detail, but let me mention about three divisions. Domain expertise means a domain in which they are working. If they are working in a pharmaceutical company, they should need to understand pharmaceutical company. suppose they are working in a big organization where it deals with only goods or merchandise, they need to understand those terminology that deals with merchandise. So according to the field, say suppose they are working in a hospital, they need to understand the methods applied or techniques they are talking about in the hospital. The last one is the soft skills, some of the skills which are not related to subject, but within themselves they have to develop. Let me go into the details of this. Technical skill. Technical skill comes with the subject itself, statistics subject. So that is what is the technique? We are using statistical techniques. So that is necessary. Understanding probability theory, hypothesis testing, regression analysis, time series analysis, all these things. Say, for example, when we are talking about hypothesis testing, say, for example, hypothesis testing, what are the concepts there? So there will be null hypothesis and alternatives. The first of all, one should need to understand, suppose given a problem, which can be taken as a null hypothesis, which can be taken as an alternate hypothesis. See, what happens normally in a classroom, hypothesis, null hypothesis given, alternate hypothesis given. But when they go for applying these methods for some data, if data is given to them, then they'll have to understand which one should be chosen as a null hypothesis, which one is an alternate hypothesis. It is not that always null hypothesis should be equal to 0 or mu1 is equal to mu2. It could be different type, different methods. So in inference, we have different type of null hypothesis. So which is to be taken as null hypothesis? Okay, that is one aspect. Say again, testing of hypothesis, once null hypothesis given, and for the given data, based on the assumptions, we will have number of test procedures. And once the test procedure is applied, then the final result will come as H0 is accepted or H0 is rejected. Say H0 is rejected as a more powerful result, and it will tell you something. It will say that 95% confidence that whatever we have said is correct. Whereas, suppose the conclusion is that null hypothesis is accepted or not rejected, then can we say that it is so much a powerful result? How much powerful is we are really depending on the parameter existing. So because see what happens in the testing of hypothesis, the null hypothesis, the procedure is null hypothesis is assumed to be correct, and you are assuming that null hypothesis is correct, and finally saying that based on the data we are getting the result that null hypothesis is accepted. That means say for example, suppose the data follows, we assume that in testing goodness of it, we assume that the data follows gamma distribution, and ultimately we could not reject the null hypothesis, so we conclude that gamma distribution is accepted. So we say that data follows gamma distribution. But what I'm saying that suppose we take another somewhat closer distribution other than gamma distribution, maybe something like Bible distribution, and it may so happen that even Bible distribution is accepted. So this type of critical thinking or the knowledge of null hypothesis, alternate hypothesis, what is meant by rejecting, what is by accepting, these type of conclusion, how to take conclusion and how powerful is our conclusion, this type of concepts, knowledge of statistics is necessary even while you are studying these subjects. Hence, I would say that you should have a strong statistical skill. It may be any of the subjects. So understand how these results are applied and how it is evolved and how it is related to the data is very important. And there are also mathematical skills which are required. Say, for example, in understand, we need to understand the calculus, Linear algebra, differential equations. In many of the cases where we are developing statistical theory for applications of various methods. All of you are able to hear, right? I'm
Yes,
audible.
sir. Yes, sir. Yes, sir. You are audible.
Someone should say, because
Yes, sir. You are audible, sir.
okay, okay. Any other suggestion? Okay,
No, sir. It is fine.
okay, okay,
Go ahead, sir. Go ahead.
okay. Thank you. Okay, now I'll just take a very simple example. A very simple example comparing standard deviation. Let me say that I have two samples, sample one and sample two. A mean score for both of these is same, maybe 75 or 74, somewhat close. I would say that they are almost same. And the standard deviation for the first sample is 10, and standard deviation for the second one is 12. So normally, normally even or even otherwise, we conclude that the first sample is consistent, right? First sample is consistent. Second sample is compared to second sample. First sample is consistent. But this is a part of the data depicted. There is something missing here, or something additional information is given. Instead of saying that it's missing, instead of using only this information, suppose I use additional information. Additional information is that the sample size is 20 in case of standard deviation is 10, whereas 200 in case of sample standard deviation is 12. Okay, so now what is the conclusion? I do say that yes, 10 is a consistent one, but when we are looking at 200 observation from the same population, if it is from the same population, 200 observations says that the standard deviation is 12, which is this 12 standard deviation is more meaningful compared to standard deviation of 10, and hence I would accept the standard deviation 12 as a more accurate answer. And why this is, and it is called as a reliable, it is more reliable. The second sample is more reliable than the first sample. The simple reason is that the sample size is larger. So what is the interpretation here? What happens is, why it is 10, why it should not be slightly more than that, because the larger sample gives 20 to 200 observations give you standard deviation of 12. So only after realizing that the sample size is 12 or 200 in the second sample, instead of going for first sample, we may say that okay, instead of going for second sample, I will better compare the first sample as the not as reliable as the 12, because it has come because of variations. Maybe the 20 observation did not vary much when we are this is a randomization, just by random chance, by some chance we got observation which are closer together, hence we got 10, which says that it is more consistent compared to the other. So this is the way. You see, normally standard deviation less is accepted, but when the sample size is known, we tend to move that okay, the second sample is more reliable, so let us go with the second sample result. So this is one type of understanding of data, say understanding of standard deviation. Now let me talk about causation, or cause and effect. Say drinking green tea will reduce your weight. This may be, I don't know whether this is given as advertisement. I'm just talking about a statement. Drinking green tea will reduce your weight. If you take data related to those who are taking green tea and their weight and the comparison, and then it is relation is correct. This type of relation is going to be correct. So we will say that green tea is going to impact very highly for reducing their weight. But here what happens is there may be additional information. Additional information can help them to really whether the conclusion is very strong or it is not so strong. Say, for example, when normally people who are drinking green tea are more concerned about their weight, health. So green tea, people are taking green tea because they are concerned about the health. So people who are taking green tea are related with the people who are concerned about their health, and hence that will add on their reducing the weight. So the simply giving interpretation based on correlation or measure of any association may not be so much accurate. We'll have to see what other impacts, what other factors may impact these type of conclusions. So that is another example in saying about concepts. Okay. Then understand the application problem. You need to fully comprehend the problem under consideration and its objective before going into data analysis. A data is given, then you need to see the background of the data. You need to see what is the objective, the problem, what is the question asked, what is to be analyzed, and based on that, you may able to see the proper connection and proper method of which application should be applied. Problem may come from business, healthcare, biostatistics, government or public policy. So different areas it may come, and from different areas when it is coming up, so their data will have some properties. It also, you see, understanding background is also going to give us something about properties of the data. See, the two data set is given. If the two data sets are coming from different sources, the assumptions what we are applying for these two data sets need not be the same, because assumptions will depend on what type of nature of the data we have arrived. So according to the assumptions, the methods applied to the data could change. That is why understanding the application is very important. Get correct, as far as possible, get correct information about the data or industry or business problems. So getting so much of information about data, not only data, but data coming from what source and for what purpose, how it is collected. These are very important factors. So when I say how it is collected, the sampling process is also very important. So the next speaker will speak about sampling. So data, when we are talking about assumptions, also relates with which method of sampling is used, how the samplings are, how these sampling methods are used, also playing an important role. And then afterwards, after understanding these things and then data, then you convert that as a statistical problem. So it is not simply applying statistics. So understanding data and applying statistical problem, and these are possible for a statistician much better way. So they can understand what are the different methods available, what are the available for the assumptions, related assumptions, the type of data. Okay. Now, when we are getting, this is applicable in a large data set. So when it is data set is coming up, one of the problems is that they contain errors, the missing values, inconsistencies, or duplications. These types of problems we may face. Say, it may not be well structured. Sometimes we need to create it, as I say, a data comes in a very haphazard manner, then we need to arrange them in a tabular form. ಅಂದರೆ ಡೇಟಾ ಬಂದಾಗ ಅದರಲ್ಲಿ ಅದು ಟೇಬಲ್ನಲ್ಲಿ ಡೈರೆಕ್ಟಾಗಿ ಇಡುವಾಗಿಲ್ಲ, ಅದನ್ನು ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಅದ್ರಲ್ಲಿ ನೋಡಬೇಕು ಮಿಸ್ಸಿಂಗ್ ವ್ಯಾಲ್ಯೂ ಇದ್ರೆ ಹೇಗೆ, ಮತ್ತು ಡುಪ್ಲಿಕೇಶನ್ ಇದ್ರೆ ಹೇಗೆ, ಮತ್ತು ಔಟ್ಲಯರ್ಸ್ ಇದ್ರೆ ಹೇಗೆ, ಅದನ್ನೆಲ್ಲ ನೋಡಿಕೊಂಡು ಕನ್ವರ್ಟ್ ಮಾಡಿ ನಮಗೆ ಟ್ಯಾಬ್ಯುಲರ್ ಫಾರ್ಮ್ನಲ್ಲಿ ಮಾಡಿದರೆ ಒಳ್ಳೆಯದು. ಟ್ಯಾಬ್ಯುಲರ್ ಫಾರ್ಮ್ ಮಾಡಲಿಕ್ಕೆ ಆಗದಿದ್ದರೆ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಅನ್ಸ್ಟ್ರಕ್ಚರ್ಡ್ ಡೇಟಾ. ಆ ಅನ್ಸ್ಟ್ರಕ್ಚರ್ಡ್ ಡೇಟಾವನ್ನು ಸಾಲ್ವ್ ಮಾಡೋ ಮೆಥಡ್ಸ್ ಸ್ವಲ್ಪ ಬೇರೆ ಇದೆ. ಸೊ ಸ್ಟ್ರಕ್ಚರ್ ಡೇಟಾ ಮಾಡುವ ಮೆಥಡ್ ಬೇರೆ ಇದೆ. ಆದ್ದರಿಂದ ಫಸ್ಟ್ ಥಿಂಗ್ ಈಸ್ ವೆದರ್ ವಿ ಕ್ಯಾನ್ ಕನ್ವರ್ಟ್ ಇಟ್ ಎಸ್ ಸ್ಟ್ರಕ್ಚರ್ ಡೇಟಾ, well structured data. Okay, that is the first reality. And all these problems mostly coming in secondary data. Suppose ನೀವೇ ಕಲೆಕ್ಟ್ ಮಾಡಿದ ಡೇಟಾ ಇದ್ರೆ ಅದು ಒಂದು ಟೇಬಲ್ ಅಲ್ಲೇ ಬರ್ತದೆ, ಆದರೆ ಅದು ಸಿಸ್ಟಮ್ಯಾಟಿಕ್ ಆಗಿರ್ತದೆ. ಬೇರೆಯವ್ರು ಕಲೆಕ್ಟ್ ಮಾಡಿದ ಡೇಟಾ ಇದ್ರೆ ಅದು ಕಲೆಕ್ಟ್ ಮಾಡಿದ್ದು ಮಿಸ್ಟೇಕ್ ಇರ್ಬೋದು, ಇಲ್ದಿದ್ರೆ ಅದು ಎಲ್ಲೆಲ್ಲಿಯೂ ಇರ್ಬೋದು, ಡುಪ್ಲಿಕೇಟ್ಸು ಇರ್ಬೋದು, ಇಂಥದ್ದನ್ನು ಮಿಸ್ಸಿಂಗು ಇರ್ಬೋದು. ಇದನ್ನೆಲ್ಲ ನೋಡಿಕೊಂಡು ಇದು ಮಾಡುವಂಥದ್ದು, ಇದಕ್ಕೆ ಹೆಸರು ಡೇಟಾ ಕ್ಲೀನಿಂಗ್ ಅಂತ. ಡೇಟಾ ಕ್ಲೀನಿಂಗ್ ಈಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಆ್ಯಂಡ್ ಟೈಮ್ ಕನ್ಸ್ಯೂಮಿಂಗ್. ಇದು ಹೆಚ್ಚಿನ ಕೇಸ್ಗಳಲ್ಲಿ 80% ಆಫ್ ದ ಟೈಮ್, ಈಗ ಡೇಟಾ ಅನಾಲಿಸಿಸ್ ಅಂತ ಮಾಡಿದರೆ, ಅನಾಲಿಸಿಸ್ ಮಾಡುವಾಗ ಡೇಟಾ ಕೊಟ್ಟರೆ 80% ಆಫ್ ದ ಟೈಮ್, ಕಂಪ್ಯೂಟರ್ ಟೈಮ್ ಗೋಸ್ ಫಾರ್ ಕ್ಲೀನಿಂಗ್ ದ ಡೇಟಾ. ಅವ ಕ್ಲೀನ್ ಮಾಡುವಾಗ ಅದಕ್ಕೆ ಡೀಪ್ ನಾಲೆಜ್ ಆಫ್ ಸಬ್ಜೆಕ್ಟ್ ಈಸ್ ರಿಕ್ವೈರ್ಡ್. You need to understand, as I said earlier, what is the assumption, which method to be applied. Depending on the method, you need to prepare your table. Say, ನೀವು ಯಾವುದಾದ್ರು ಸಾಫ್ಟ್ವೇರ್ ಯೂಸ್ ಮಾಡುವಾಗಲೂ, ಸೇ SPSS ಆರ್ ಜಮೋವಿ ಯೂಸ್ ಮಾಡುವಾಗ ಅದರಲ್ಲಿ ಕಾಲಮ್ನಲ್ಲಿ ಹೇಗೆ ಪ್ರಿಪೇರ್ ಮಾಡಿ ಇಡಬೇಕು, ದಟ್ ಈಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫ್ಯಾಕ್ಟ್. ಸೊ ಯು ನೀಡ್ ಟು ಪ್ರಿಪೇರ್ ದಟ್. Entire data, given data should be converted and then placed it in a specific format for applying any other method, including ನಮ್ಮ ಕೋಡಿಂಗ್, ನಮ್ಮ ಆರ್ ಪ್ರೋಗ್ರಾಮ್ ಇಲ್ಲ ಇದ್ರೆ ಬೇರೆ ಯಾವುದಾದ್ರು ಪ್ರೋಗ್ರಾಮ್ ಅದು ಕೋಡಿಂಗ್ ಮಾಡೋದಾದ್ರೆ ಇದು ಬೇಕಾಗ್ತದೆ. ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ನಾನು ಡೇಟಾ ಕ್ಲೀನಿಂಗ್ ಇಲ್ಲದಿದ್ದರೆ ಏನಾಗ್ತದೆ ಅಂತ ಒಂದು 2 ಸಣ್ಣ ಕತೆ ಹೇಳ್ತೀನಿ. ವೆನ್ ಮಿಸ್ಸಿಂಗ್ ಓವರ್ ಬಾರ್ ಮೇಡ್ ಎ ಸ್ಪೇಸ್ ಕ್ರಾಫ್ಟ್ ಕ್ರ್ಯಾಶ್ ಇನ್ 1962. ಸೊ ನಾಸಾ ಅಂದರೆ USA-ದಲ್ಲಿರುವ ಸ್ಪೇಸ್ ಕಂಪನಿ ನಾಸಾ, ದೇ ಲಾಂಚ್ಡ್ ಇನ್ 1962 ಎ ಸ್ಪೇಸ್ ಕ್ರಾಫ್ಟ್ ಟು ವೀನಸ್ಗೆ ಹೋಗ್ಲಿಕ್ಕೋಸ್ಕರ. ಅದಕ್ಕೆ ಹೆಸರು ಮೆರಿನಾರ್ ಅಂತ. 1962 ಮಾಡಿದ್ರು. ಇದು ಏನಾಯ್ತು ಅಂದರೆ ಎಲ್ಲ ಕರೆಕ್ಟ್ ಆಗಿತ್ತು, ಆದರೆ ಒಂದು ಕಡೆ ಕೋಡಿಂಗ್ ಮಾಡುವಾಗ ಒಂದು ಕಡೆ ಓವರ್ ಬಾರ್ ಅಂತ ಇರ್ತದೆ. ಈಗ ಓವರ್ ಬಾರ್ ಇದ್ದರೆ ಮತ್ತು ಓವರ್ ಬಾರ್ ಇಲ್ಲದಿದ್ದರೆ ಏನಾಗ್ತದೆ ಅಂತ. ಓವರ್ ಬಾರ್ ಇದ್ದರೆ ಅದು ಈ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಸ್ಪೇಸ್ ಕ್ರಾಫ್ಟ್ ವಿಲ್ ಬಿ ಗ್ರ್ಯಾಜುವಲಿ ಚೇಂಜಿಂಗ್, ವೆರಾಸ್ ಓವರ್ ಬಾರ್ ಇಲ್ಲದಿದ್ದರೆ ಸಡನ್ ಆಗಿ ಚೇಂಜ್ ಆಗ್ತದೆ. ಇಲ್ಲಿ 1962 ಇದು ಮಾಡಿದಾಗ ಇದಕ್ಕೆ more than 500 crores of money is spent, and ಒಂದು ಕೋಡಿಂಗ್ ಪ್ರಾಬ್ಲಮ್, ಕೋಡಿಂಗ್ನಲ್ಲಿ ಓವರ್ ಬಾರ್ ಇರಲಿಲ್ಲ. ಅದರಿಂದಾಗಿ ಸ್ಪೇಸ್ ಕ್ರಾಫ್ಟ್ ಹೋಯಿತು. ವೆಲಾಸಿಟಿಯನ್ನು ಚೇಂಜ್ ಮಾಡಬೇಕಾಗಿದ್ರೆ ಅದು ಸಡನ್ ಆಗಿ ಚೇಂಜ್ ಆಯಿತು. ಸಡನ್ ಆಗಿ ಚೇಂಜ್ ಆದದ್ದು ಬಿಕಾಸ್ ಮಿಸ್ಸಿಂಗ್ ಓವರ್ ಬಾರ್. ಸಡನ್ ಆಗಿ ಚೇಂಜ್ ಆದದ್ದು ಅದು ಕಂಟ್ರೋಲ್ ಬರಲಿಲ್ಲ. ದೆನ್ ಸೆಲ್ಫ್ ಡಿಸ್ಟ್ರಕ್ಷನ್, ಅದನ್ನು ಮತ್ತೆ ಅವರೇ ಡಿಸ್ಟ್ರಕ್ಟ್ ಮಾಡಿದ್ರು. ಯಾಕೆಂದರೆ ಎಲ್ಲಿಗಾದರೂ ಹೋಗಿ ಎಲ್ಲಿ ಬೀಳ್ತದೆ, ಭೂಮಿಗೆ ಬಂದು ಬೀಳ್ತದೆ ಅಂತ ಹೇಳಿ ಅವರೇ ದೇ ಹ್ಯಾವ್ ಸೆಲ್ಫ್ ಡಿಸ್ಟ್ರಕ್ಟೆಡ್. ಆ್ಯಂಡ್ of course that was a failure. The next one is a success. Okay, they could understand what is happening. So this is overlooking a small mistake in a coding. So this is also a type of data cleaning process. When we are looking into the program, we have to see that very carefully how it is free of any error for the situation itself. Okay, program may be working. Program was working because it says that change the direction means it will change the direction. So how it is changing the direction is not understood for them. Okay, that is one case. Another is in 2012 London Olympics, ticketing disaster. This is called as a ticketing disaster. So what happened is 2022 Olympics, in one stadium, there are so many events are taking place. In one stadium, the software they have prepared by mistake, one more zero is added to the number of seats available. Instead of 10,000 seats available, one more zero is added, and it says that 1 lakh tickets are available. So what happens? The tickets are issued. Tickets are issued with the ticket seat numbers. So seat numbers go up to 1 lakh. Okay, after the event, so much of tickets were sold. So the number of tickets sold is not equal to 10,000. It is much more than that, much more than the capacity of the stadium. So what happened was, when they are trying to enter in, their ticket numbers or seat numbers will not match with the existing places. So as a result, only a few of them could enter the stadium, and most of them are not able to enter the stadium. And what happened? Lot of fans, they made really so many things, but what happened? They could not be allowed inside. So the organizers really lost so many. They had to face these Olympic fans, and they have to reimburse their amount, and their reputation is lost. So this is the type of loss that happens just by overlooking the fact that that contained one more zero. See what happens in data handling. Data, we have to be careful. So you have to be extra care when you are doing your work with the numbers, or numbers or anything coding. So the first example is about coding, another is inputting a number. So these are certain problems. Okay, data manipulation, ability to clean, organize, restructuring, and managing outliers. All these things are data manipulation. Data manipulation is, as I said earlier, can we convert it to a different format? Say, for example, sometimes we put the data into Excel or CSV format. CSV format is one single sheet in an Excel. So like that, when we are managing to do that. So when we are trying to do that, if there are some outliers, if they are not really belonging to that population, we normally statisticians do suggest that outliers should be removed from the data so that it looks uniform, more suitable data. Thinking that outliers may come from by mistake, or they come from other population. But I will give you an example where ignoring outliers is not so appropriate. Say, for example, Dr. Francis Kelsey examined a case. In late 1950s, a new drug, tele- thalidomide, was marketed as a miracle cure for morning sickness for pregnant women. So normally, pregnant women will have this vomiting sensation in the morning, or morning sickness they will have, and this was a very good cure. But then what happens was, large data, when they look it into, there were small outliers where it is not working very well for only a few of them. Not even 1 in 1,000. Maybe very few of them had the problem of severe limb deformities they had. So Dr. Francis Kelsey examined this, and then she recommended to the recommending authorities. Actually, this was recommended even after statistical test, because the outliers. See, normally what happens is one or the two few cases will be outliers, and that can be ignored, and that is what is done in the beginning. And then Dr. Francis Kelsey pointed out that this is a serious problem that will create severe limb deformities. And actually, this was sold to European countries, and European countries also found this type of limb deformities in many of the cases. So in this case, the outliers should have considered, and in fact, the sanctioning authority afterwards considered outliers. By considering outliers, this drug was banned. So let's look at the statistical applications, how it is coming up. Normally, we have to see beyond whatever we are studying in our career, in our student life. So you have to see really the situation and decide. Program skill is another important factor we need to understand. A programming skill, maybe some programming may be using R or any other program essential for working. And another application is spreadsheet. So spreadsheet is like Excel. So Excel is very good for the starting for any other persons, very statistician to use Excel. All of statisticians need to understand how Excel is working, and a lot of things can be done using Excel. Say even your testing ANOVA, simple ANOVA can be carried out, t-test can be carried out, or finding regression can be done using spreadsheets. Anyway, feeding is simple in a spreadsheet, and hence it is easier to work with spreadsheets. So that is one aspect. So all of you should learn to use Excel. Then learn how to present the data visualization. So effective way of visualization is, and then visualization will communicate the things very fast. Say if those who don't understand the conclusions written in words, but if they are given in graphs, they will understand. Explaining the conclusions using graphs will be a very effective one. And there are various graphical representations, and these graphical representation can be used. Visual display, analyze the clarity, and interpretation wise easier. And a different type of graphs will give different dimensions of the data. So this graphical representation is also important. And learning of some software, as I said earlier, say maybe SPSS or equivalent to that is Jamovi, or R program, or Python program, or SAS and Stata. They are, if one knows about these things, they can work better. And problem solving is an important aspect. So when we are problem solving means we need to see the problem first before going to any other things. We have to think about how this problem can be solved, how best this can be given to the the decision makers. What type of solutions can be given to the decision maker. So problem solving is a really very important step in beginning of the data analysis. Okay. Data sometimes can be small. When I said that you have a large data, it is not necessary that always we have large data. We do encounter number of cases small data sets, especially when a specific application is considered. Even if it is digital information, they could be very small. Or if it is filtered data, suppose we consider filtered data from the digital information, that could be small. Or manually collected data, they will be small. And say for medical purposes, other purposes, specific purposes, when we collect data, we need not have very big data. But in a lot of commercial applications, we get big data. There are cases where even small data can be possible. So when I say big data, digital data, don't understand that always it is big data. There could be small data, and especially when it is small data, all the methods, they can be easily applied, whatever you have studied. And care should be taken while collecting data. So always this will also be explained in a sampling, I suppose, how the sample should be collected, how it is randomly can be collected, and then depending on the problem, various assumptions have to be satisfied. So whether it satisfies those type of assumptions, or when we are collecting the data, what type of measurements should be considered, whether it should be simply a group. Say, for example, when we ask a question, what is your age? Whether we have to give the perfect age in integers or in a group, say 10 to 20, 20 to 30, depending on the problem. So say how data should be taken should be decided in the beginning itself. So depending on that, we can see applications, and depending on that, we can reduce the complication in a data analysis. And which type of data should be developed is another goal. Now, this is about technical skill. Now, let me talk about domain skill. I'll take another 15 minutes, or how much time I have?
Sir, still 15 minutes you can take, sir.
Okay. 15 minutes, okay. So domain knowledge is, I'll go slightly faster, about eight slides are there also. Domain knowledge refers to the business where you are taking the data, a business model where it should be applied. The right questions and the right persons, whether you can get this one. Say, for example, statisticians work in healthcare industry, maybe hospital, maybe pharmaceuticals, in these areas, or have a strong understanding of medical terminology and their regulations and the specific challenges, and then what are the opportunities. So this will help. So this is not statistics, but this is domain knowledge. So where they are going to apply. Say, normally what happens if you go to a hospital and or a pharmaceutical company and then you're talking, they will have their own terminologies. They have their own way of dealing with data. They are talking about data is different. And if you're not able to understand, even when they're talking about data, then you may feel something missing. So better to understand the terminology. And even for the case of testing of hypothesis, when we consider in a company is different, in a hospital is different, pharmaceutical is different, different way there are lots of lots of variety of statistical tests in the pharmaceuticals or in a healthcare. So that is something extra. And say, for example, designed randomized controlled test trials in this where we are comparing two types of treatments and how this can be controlled, how this can be carried out. Maybe what we have is one is controlled drug, another is treated drug, and then how these controlled drugs can be randomized, and then the data can be taken, how it will be analyzed. So this is some extra knowledge. Say, after studying BSc, when you're going for a job, so need to understand, maybe even after joining the job or before that itself, if you understand, still better, because in the interview or in the selection process, the knowledge will help to filter you as one of the candidates. So if you have this knowledge and or have this some type of certificates, that is always helpful. Just certificate of even attending some workshops will help you, even the smallest one, if I say. But there are more things can be done. Understanding what is placebo effect in a pharmaceutical cases. Blinding means when the tests are carried out, these drugs are given to the patients. Now, given to the patients, sometimes patients will not know what is this. That is one single blinding. The double blinding is that the person who is giving also do not know, person who is taking also do not know. But there is some outsider who is controlling this, who is able to monitor this. So that is what blinding. Blinding is very well used in the drug developments. So that is really useful. So it's not something which we cannot understand. Statisticians are easily able to understand these concepts, and why it is used can also be easily understood, and it can reduce bias. Okay, and various other methods of bias reduction also can be seen. Say, for example, if you are taking data from a hospital, there is maybe a data from MRI, or it may be CT scan data or lab test data. and the various measurements are made there, various observations we get there. You need to understand them. So understanding other area is a domain knowledge. The knowledge of that domain is helping you to work with the that company. And knowledge of regulatory and ethical considerations. See, there are a lot of ethical considerations you need to consider. Say, for example, if you are taking some data from a person, whether this can be used in general, or there are some private issues, or it cannot be disclosed. These type of, or it is ethical, or even it is a regulation conditions. So one need to understand regulations or ethical considerations when you consider data. Understanding the specific industry, as I said earlier, what type of industry it is need to be understood. Business model can be developed based on the companies, or getting valuable information about the company. What are the challenges, what are the regulations, and what are the opportunities. All these things can be, if you understand, that can be, then data analysis is easier, statistical work is easier. Talking to domain experts is how we can develop these things. Continuous reading about and staying up to date. Say, for example, if you are going for a pharmaceutical company, reading about pharmaceutical company, an article based on certain issues of the pharmaceutical company will certainly help. Attending industry conferences certainly can help if possible. Gaining practical experience. They say sometimes intern, or you take up a project and work under them, you get some practical experience, then certainly your domain knowledge will help. So having domain knowledge is an important for statistician to become statistician, because it allows them to better understanding of a specific problem and challenges that their organization or clients are facing, and to develop more effective and relevant solutions. Then other skill is, last one I mentioned, is soft skill. The soft skill is first, the foremost is communication skill. Communication is how do you communicate to them. Communication needs to understand what they should understand, what you are speaking. You should understand what they are speaking about. So normally, if statisticians talk about a hypothesis rejected, the conclusion is this, and that type of is not a correct conclusion. Correct communication. I'm sorry. Correct communication. When you're communicating with the company, you have to translate your conclusion in their words. So this type of, then again, communication is also helpful in getting more information about data analysis itself, and more information about implementation of the data. So communication skill is very, very important factor. It plays an important role, and this is where it is going to be very helpful. Okay, I will conclude within 2-3 minutes. Okay, then ability to articulate and mentioning the result. So both oral and then you should have a curiosity. You should have a curiosity. Intellectual curiosity inspires the statisticians. Say, when you're looking about the data, you have to see every factors. You should be curiously looking into data, and so that you're able to answer it more perfectly. So understanding more, and you can adapt with some new methods. Curiosity results in coming up with a new method. Okay, and the process of mentioning, communicating to them is like a storytelling. Storytelling has a sequence, and something like that you should able to communicate to them like a storytelling. And critical thinking is required. Statisticians should be critical thinkers. Analyzing problems objectively during data interpretation is crucial before establishing opinion, to help their findings bring the organization closer to the desired one. So critical thinking is required, even when the problem is whether this type of method can be applied, why how, when, all these type of questions will result in critical thinking. Okay. Uh, then collaboration with them, team management, and ethical decision making. So these are certain factors. So I conclude here. Uh, Before conclusion, one slide is about how you can. I mentioned all these things. How you can acquire these is another question, right? So I said all these. When you are studying BSc, how you can do that? So you should have a curiosity when you're learning. As I said, when you're learning statistics, you learn statistics with this curiosity. When it cannot be applied, when it can be applied, like this, and look at real world applications of these methods, whatever you study. Simply not a formula is applied, where it can be applied, and be curious and think critically for all the problem. Another one is solve puzzles, riddles, challenges, challenging problem in the statistics or even mathematics or some other puzzles. It will improve your thinking ability, and participate in competitions. If you do that, your skill will improve. Other technical skill or even other soft skills will improve. With this, I open the platform for others. I think there will be a lot of questions. I will try to answer if I can do that. Okay. Thank you.
Thank you, Pakal sir, for your insightful address. Your words have certainly set the tone for a day of deep learning and reflection. Thank you, sir, once again.
Okay. Any questions from chat box?
Yes, sir. We have received some questions from the participants.
Yeah. Maybe quickly I can answer
Yes,
that.
yes. On behalf of them, I will ask, sir. The first question is,
Yeah.
you can also see on the screen what is mean by outliers. If
Okay.
in
Okay.
case we have so many of outliers, how to handle those?
See, outlier handling is not very simple. See, normally one rule is that simple rule. It's not a very strict rule. If the observations are following normal distribution, they will be from minus 3 sigma, mu minus 3 sigma, mu plus 3 sigma. So if the observations are beyond this, it can be considered as outlier, but they are not. But this is a very, very vague rule. So something, this is one way. What is meant by outlier means, we say outlier when they are not really, they are not supposed to belong to this population, this data. They somehow they have crept in to this particular data. As far as our analysis is concerned, this data is not relevant. We can remove that. So that is what is meant by the outliers. But when we are removing that, I already mentioned about this problem, and there are other cases also, other fields also. Sometimes outliers are very precious. They contain more information. Why that outliers are coming up if they belong to the same population? So whether it belongs to the same population or not, we do not know. So when we do not know, normal rule is that if it is beyond, say, if the all the observations are ranging from say for example some 40 to 60, if some observation 120, this is certainly not belonging to this data set, and hence it can be considered as outlier. So outlier analysis, if there are too many, then really you have to make it as a categorization of data and classification of data. And even there is a bunch of outliers outside means, it cannot be ignored. You can classify as a one group and study that separately. Okay.
Okay.
Next
Thank you.
question.
Thank you, sir. Next question is, are there any easy to use tools or software for beginners to practice the data cleaning?
Oh, data cleaning, actually, a simple thing is it's not very easy. It can be easy also, but not very easy. Data cleaning process takes a lot of time, because there are lots of types of cleaning. So say for example in a Excel, if data is stored, whether they are in uniformity that can be seen, and they can be manually can be done, but there are number of softwares available to clean the data. So depending on type of cleaning method, you can apply, and simply applying one particular method, the data will not be cleaned. So you'll have to do a repeated process of applying different methods. Not very simple. Okay, briefly, that is the answer.
Okay. Thank you, sir. Thank you so much.
Okay.
Desai madam, over to you.
Okay.
Thank you, Pakal sir, for your insightful address. Now, I would like to invite Mr. M.P. Myagedi, Faculty Department of Statistics, to welcome and introduce our second speaker, Dr. Ganga Boraiya Adanaya, Professor Emeritus of Statistics and Research Head at Dayanand Sagar College of Dental Science, Bangalore. Sir, over to you.
Thank you, ma'am. Good afternoon, everyone. It's my immense pleasure and privilege to address our honorable resource person, Dr. Ganga Boraiya, sir. He was completed his BSc as a combination of PMS in 1979 at Bangalore University, and also he completed his post-graduation MSc in Statistics in 1996 at Bangalore University, and he was completed his PhD in Statistics in 1996 from Bangalore University. And he was survived as a biostatistician in population-based cancer registry, Kidwai Memorial Institute of Ecology at Bangalore in December 1981 to May 1983. And also he was served as a tutor and assistant professor and associate professor and professor of statistics in Kempegowda Institute of Medical Science at Bangalore in May 1983 to September 2016. Now presently surviving as a professor of Emeritus and research head in Dayanand Sagar College of Dental Science, Bangalore, and also surviving as a adjunct professor in Birla Institute of Technology and Science, Pilani, and also serving as a visiting professor in so many institutes like and also the visiting professor of RGH Public Health Institute, Government Homeopathy Medical College and Hospital, Bangalore, Manipal University, Bangalore Center, and Dayanand College University, Bangalore, and College of Pharmaceutical Science and College of Physiotherapy and College of Nursing, College of Public Health, and KLE Institute, University College of Pharmacy, Bangalore, Alamin College of Pharmacy, Bangalore, Acharya and B. Reddy College of Pharmacy, physiotherapy at hospital administration. And he was conducted more than 150 workshops as a resource person on research methodology and biostatistics for the medical, dental, physiotherapy and pharmacy, nursing and health science facility and postgraduate. And he was survived as a trainer of the SPSS and R publications and also a constant consultant trainer in Southeast Asia Regional Bureau of SPS and R. In that also, he has published so many articles in taking as a 100 international, 50 international and 20 national and 3 state articles are there. And he was served as a secretary of Karnataka Association of the Community Health and also vice president of KACH and president of KACH, and he has been scientific committee member of several institute like Indian Surgical Institute and Indian Public Health Association and Karnataka Association of Community Health and Association for Prevention and Control Rabies in India, and also a secretary of Karnataka Association of Community Health, and also a member of a scientific member of Dayanand College of Dental Science and Bangalore, Government Homeopathy Medical College, and Indira Gandhi Institute of Child Health, Bangalore, Rajiv Gandhi Institute of Chest Diseases, Bangalore, and Fortis Hospital, Bangalore, and Prabha Eye Hospital, Bangalore, and KLE College of Pharmacy, Bangalore, KIMS Nursing College, Bangalore, and RV College of Physiotherapy, Bangalore. And also he has been the IEC member of Dayanand College of Dental Science, Bangalore, Government Homeopathy Medical College, Bangalore, Indira Gandhi Institute of Child Health, Bangalore, Rajiv Gandhi Institute of Chest Disease, Bangalore, and KLE College of Pharmacy, and KIMS Nursing College of Bangalore, and RV College of Physiotherapy, Bangalore. And now presently he is a member, he is a IEC chairperson of Motherhood Hospital, Dayanand College of Dental and Dental Science College, Bangalore. This is a brief introduction of a resource person. Thank you so much for giving this opportunity. Thank you, one and all. Over to you, ma'am.
Thank you, Magdi, sir. Now, I would like to take this honor to invite Dr. Ganga Boraya Adnaya, Professor, to deliver his lecture. Over to you, sir. Sir, please. Sir, over to you, sir.
Sir, you have to unmute yourself, sir.
Okay. Thank you very much. Without wasting time, I'll straight away go to my talk. Fine. The topic which I'm going to address is techniques and sample size determination, which I felt that it is important for all of you if you are going to involve in data collection and also in research. I need a prerequisite. The prerequisite is related to probability. So, probability we define as likelihood of occurrences. In simple word, likelihood of occurrences of an event. Yes, we need to define an event. For this event, we have to find the likelihood. If I denote A for an event, then probability of that event is what we want to find out. So, the other names used for the probability is random, likelihood, etc. With this background, coming to the sampling per se, this observed data is what we are looking for. This observed data, that is the data what you are going to see, will be a combination of some truth, that is actuality, some bias, and some random error. As far as possible, we have to reduce this or remove this bias. Otherwise, we also call it as systematic error. So what is a systematic error? Simple example. We all travel by auto rickshaw. Let us say from home to our workplace, we travel in auto rickshaw and end up with paying around 110 rupees one side regularly. Suppose on a particular day, if the auto meter shows 140 rupees, we become alert. How come? Every time I was paying 110 rupees and today the fare is 140 rupees. When we try to analyze the causes, try to identify the causes, we all know that any electrical, electronic, or mechanical devices are supposed to be calibrated regularly. Perhaps the autometer was not calibrated regularly, periodically, thereby this 30 rupees would have been increased. So, by identifying the causes like non-calibration of the autometer, right, we can detect that there is a bias and this can be removed by calibration. But, however, so this is possible to remove it. But this random error, we do not know how it occurs. Same example, instead of 110 rupees, if the autometer shows 113 rupees, we can't ascertain the cause. Maybe from home to the workplace, there may be 3 signals, 2 signals. Sometimes the auto might be stopped at every signal. When they stop it, the waiting charges in the autometer will be running inside, which is invisible, but which gets added with the main fare. Probably that might be one of the reasons why this 3 rupees would have been increased, and we can't guess which day we are going to stop the auto at the signal, which day we pass through, or else the police person for some reasons would deviate the route. Even that also would add up to this increase in 3 rupees. So we attribute this to random error. So ultimately, our observed data should be only based on truth, and of course not possible to control this. So it's a random error. This must be, bias must be removed. Fine. Now, the sample design, that means selection of samples. There are 2 types. One is called as probability sampling, other one is non-probability sampling. In probability sampling, it is a procedure that assumes all the units in the population have some probability known in advance being selected. If there are 100 students in a class and I want to choose 10 students, assigning equal probability, every student will have a chance of selecting, right, into the 10 samples as 1 by 100 for the first sample. Usually we go with sampling without replacement, because sampling with replacement leads to repetition of the same sample being selected again and again. So we prefer to go for sampling without replacement, and hence the first sample will have a probability of 1 by 100 for every 100 persons in the group. Then 99 remains. The second sample will have a chance of 1 by 99, remaining 98, because it is sampling without replacement. And now the third sample will have a chance of 1 by 98. It goes this way. So this kind of a procedure we adopt in case of selection of samples. That is called as probability sampling. Whereas in case of non-probability sampling, the procedure in which units in the samples are collected with no specific probability structure. It's not based on any kind of a probability at all. So, with this, these are the different sampling techniques which we use under probability sampling: simple random sampling technique, systematic random sampling technique, stratified random sampling technique, multi-stage random sampling technique. In that, a special case is cluster sampling technique. And coming to non-probability sampling, these are the commonly used 4 techniques: purposive or judgment sampling, convenient sampling, quota sampling, and snowball technique. Now, why sample? Or what is the need for sampling? I have given 2 examples here. Like, to know the number of red blood cells in a person, the doctor should be satisfied with the estimate based on a few drops. Few drops, maybe 2 ml is good enough sometimes, or maximum 5 ml. So he cannot think of extracting the entire volume of blood, because that 2 or 5 ml what the technician is drawing from that person, he is going to tell the whole story about the blood picture in that individual. This is an ideal sample. Similarly, I have another example. To know the cooking status of rice cooked using cooker, it is enough if a few grains of rice is checked. But if it is cooked in an earthen pot using firewood as a cooking media, the same inference cannot be drawn, because for various reasons, the rice in that earthen pot may not have been cooked uniformly. So this type of variation, we need to analyze it before we select the samples for your study purpose. So sampling is a process of selecting units from a population of interest, so that by studying the sample, results can be generalized to the entire population from which the samples were chosen. Why sampling? Yes, population from where you are choosing the samples may be an unknown population or an infinite population. Second, even if population is countably finite, means say a large number, but we know that we are able to count them. Resources in the form of money, manpower, material, and time, generally we refer it as 3MT, required may be very huge. So, for that reason, the entire group is too large, time efficient, cost effective, and feasible also if you are adopting sampling procedure, can provide a close approximation of the population. Indeed, information actually be more accurate when based on carefully drawn samples. And it offers greater scope and flexibility than a census or complete enumeration. Of course, this part I've already discussed. And of course, samples selected from a representative population gives a consistent and reliable results what could have been obtained from population. That is, whatever samples which you are choosing as a representative of the population gives a consistent and reliable results. These results we call it as estimates, because they cannot be the actual values like what you are able to get it from the population. It only gives you an estimate or approximate value, but if drawn as a representative sample, it gives more consistent and reliable results. So what is population? Because we need to know some of the important terminologies before we decide how to choose a sample. Population is a set of people or entities to which findings are to be generalized and should be defined explicitly before the sample is taken. Like, I'm giving an example like employees of an organization or students of an university as an example. Next is, of course, collection of data from every person or entity in the population. We call it as census or enumeration. Target population is what we need it. I don't need the entire population. See, if I'm intended to study about, let me give you an example. My intention is to study on assessing, I just taken an example, estimation of social media addiction by college students, an observational study. Suppose this is the study in which I am interested, estimation of social media addiction by college students. So I don't need the entire population of that place. I need only the college students as my target population. That is what I wanted, from whom I am going to choose the samples. That's what I call it as target population. The target population may be finite, or it even may be an infinite population, like software engineers of an organization. Infinite is software engineers in India. I don't know how many are there. It's an unknown population. Of an organization, yes, it will be a finite. But if I'm talking about software engineers of India, no, I cannot. It's an infinite or unknown population. Now, this part is very important to decide what type of sampling procedure we are supposed to use it. Target population can also be classified as homogeneous and heterogeneous. Homogeneous with respect to what characteristic that you are studying, all should be uniformly distributed. Heterogeneous means not uniformly distributed. Maybe this example should make you understand. I worked in medical college. So once we undertook a study on assessing awareness on HIV among college students. This is my topic which I had chosen. In our campus, educational campus, we have medical, dental, pharmacy, physiotherapy, nursing, biotechnology, etc. I classified them under medical science. We also have engineering students like BE, MTech, MCA, BCA, etc. I categorize them under technical. Lastly, we do have students studying in BA, BCom, BBM, and LLB. I put them under humanities. Now, if I wish to assess awareness on HIV, this group, 3 groups what I've taken is heterogeneous. The reason is very simple. The students who are studying in humanities, see, usually exposure on HIV is from curriculum in the biology subject. So these students, their exposure to HIV ceased at 10th standard. After that, they did not study anything related to this. From the curriculum point of view, they did not study. So therefore, that is one limitation. In the technical side also, here, some students studied biology in pre-university, but some did not study because they had opted for electronics, electrical, computer science, etc. in pre-university. So therefore, here also there was a restriction. Whereas all those studied under medical science, they had exposure even while studying the current course. So what I did was, I divided my medical students into 3 batches, sent one of the batches to collect data related to HIV among medical science. Second batch was sent to technical, and third batch was sent to humanities. After analysis of data on HIV, we found that 93% of the students' community under medical science were aware on HIV. It was 44% from technical side and only 18% from humanities. So, this is what I meant by heterogeneity in the population, which needs to be understood because it is going to help us in deciding which type of sampling method should be used for selecting the samples. So, of course, sample is defined as a representative part of the target population. Sampling frame is required. It is nothing but listing of all elements or individuals in the target population. Then sampling unit is every member of the target population, we can call it as sampling unit. Sampling interval also requires, because we use this in choosing samples using, say, systematic random sampling technique, where it is defined as size of the population divided by size of the sample, that is k is equal to capital N divided by small n. I have taken a simple example here. If there are 300 software engineers in an organization and you are intent to choose 50, then 300 divided by 50 is nothing but 6 is a sampling interval. So sampling methods, of course, I already explained this, I just skip it. So these are the different type of sampling methods, right? First, let me take up simple random sampling technique. Very few points we need to observe. This is based on, firstly, target population. What you are defining should be homogeneous and finite. Then, population should be relatively small, and sampling unit, because it is homogeneous, not necessarily homogeneous, but because it is finite, we are able to prepare the sampling frame. Each sampling unit will have an equal chance of being selected and selected unit by unit. Well, for selecting this, either we can use random number table, lottery method, but all these are becoming obsolete. Currently, we are using generation of random numbers, either using computer. Now, there are many mobile applications for generating the random numbers that can also be made use. So, this like this, population and sample. This is random number table, but very rarely we make use of this, since we have a easy method of generating random numbers either from the computers or from mobiles. Next is systematic random sampling technique. In this case, again, we need our population, target population, to be homogeneous and, of course, infinite or unknown. So we compute the sampling interval k is equal to capital N by N. Yes, here is a small question which arises. When the population is unknown or infinite, then how do we know the capital N value to find out the sampling interval? So we can make use of some statistical procedures to estimate or predict the size of the population. Like, for example, in hospital studies, we take the previous year admissions or previous year data, which can be made use for approximately predicting the size of the population to collect data for the present year. Similarly, in other areas also that could be made use, but we need to project or estimate size of the population. Thereby, the sampling interval can be computed. So samples are selected again unit by unit. And what makes the difference between the simple random sampling technique and systematic random sampling technique is, in simple random sampling technique, every sampling unit will be selected by assigning equal probability unit by unit. Whereas in systematic random sampling technique, only the first sampling unit is selected at random between 1 to k. Any number randomly chosen between 1 to k, we can use any method, just only one number to be chosen between 1 to k. Sometimes even our currency note helps in selecting one number randomly from the numbers printed on the currency note. And then the subsequent samples are selected at an interval of k. For example, as I showed here, the sampling interval is 6. And in case if I choose a number randomly between 1 to 6, let us assume that the number selected is 4. That means the very first sample selected is with serial number 4. Subsequently, at an interval of 6, we are going to choose it. That is 4, then next number 10, 16, 22, and so on. This is the procedure we adopt in case of systematic random sampling technique. Now, for both, what are the advantages and disadvantages, both for simple random sampling technique and systematic random sampling technique? In simple random sampling technique as well as systematic sampling technique, we are expecting that target population should be homogeneous. Therefore, in the eventuality, if our target population is heterogeneous, like medical science, technical, and humanities, there is every possibility the samples obtained may result in underestimation or overestimation. Example, if simple random sampling technique would have been applied in our example, medical science, technical, and humanities, what if majority students selected are all from medical science? You may end up with concluding almost 93% students in that educational campus are aware about HIV, which is not a true statement, because there is as low as 18% among the humanities. Or else, if majority of them are selected from, say, humanities, we may end up with the concluding there are only 18% of the students aware on HIV in that educational campus, which is also not correct. So therefore, when we are using simple random sampling technique or systematic random sampling technique, what we require is homogeneity. And if in case heterogeneous population is observed, we are not supposed to apply either simple random sampling technique or systematic random sampling technique. And one more important point, that what I have noticed in my few years of experience working in medical and dental colleges, in medical colleges and dental college studies, with specific example I'm giving, the target population will be infinite or unknown. We don't know what is the size of the population. And what we require for applying simple random sampling technique is sampling frame. I cannot prepare the sampling frame. So hence, we never recommend simple random sampling technique when the target population is infinite or unknown. We can think about some other method, but not simple random sampling technique. Next is stratified random sampling technique. This is the more suitable technique when your target population is heterogeneous. As I said about that example. So what we are supposed to do is divide that heterogeneous target population into different stratum in such a way ensure homogeneity within each stratum. Just like medical science, I've clubbed all those disciplines like medical, dental, pharmacy, physiotherapy, nursing, and biotechnology, because all of them have an equal exposure on HIV in their curriculum. So I brought it under one umbrella, so call them as homogeneous group. Similarly, technical also, they are homogeneous as well as humanities. Now, after dividing the entire students community in that campus into three different stratum by ensuring homogeneity, and also the population size is finite, we can apply now simple random sampling technique for selecting samples within each stratum. The stratification can also be looked into based upon the age group, gender wise, occupation wise, educational status wise. They also can be made use for stratification. So, advantages is cost effective, probability sampling. The process is both cost and time effective, and a larger sample can also be chosen based on numbers assigned to the samples and then choosing random numbers from the most significant samples. Okay, so it is simple and straightforward. It is non-technical. It requires basic concepts for selection of the samples. So this is non-probability sampling. It is purposive sampling, convenient sampling, and quota as well as snowball technique. In purposive sampling, otherwise also called as judgment sampling, the investigator or researchers can select the samples based purely on the researcher's knowledge and credibility. In research, for selection of samples, we define what is called as inclusion and exclusion criteria, who is the person to be included, who is the person not to be included. We define those criteria based upon which we can select the samples, which we call it as purposive sampling. In other words, investigators choose only those people whom they deem to fit to participate in the studies. Judgmental or purposive sampling is not a scientific method of sampling, and the downside to this sampling technique is that the preconceived notion of a researcher can influence the results. This must be kept in mind. And of course, this research technique involves high amount of ambiguity. Convenient sampling, or otherwise called as convenient sampling, is one of the non-probability sampling technique where samples are selected from the population only because they are conveniently available to the investigator. Investigators choose these samples just because they are easy to recruit, and the researcher or investigator did not consider selecting a sample that represents the entire population. Ideally, it is good to test a sample that represents the population, but in some cases, the population is too large to examine and consider the entire population. It is one of the reasons why investigators rely on convenience sampling, which is the most common non-probability sampling method because of its speed, cost effectiveness, and ease of availability of the samples. Just like school health examination, or something related to the students. I gave an example just now that if I want to or wish to estimate the addiction to social media by college students, right? I can choose. I cannot go by probability sampling because in a city like Bangalore, many colleges are there, get spread across Bangalore city. And if I adopt this probability sampling technique, I don't know where my samples are going to be selected, in which case I follow. And moreover, that is one part of it. Secondly, these colleges also should give permission for me to contact their students to collect the data. That is also another restriction we have it. Thereby, we prefer to choose a college which is accessible by the investigator or researcher. That is where I'm referring to its speed, cost effectiveness, and ease of availability of the samples. An example of convenience sampling would be using student volunteers known to the researcher. So researchers can send the survey to students belonging to a particular school, college, or university and act as a sample. Quota sampling. When the population once again is in heterogeneous, just like we used in stratified random sampling technique, to understand better about the population, the investigator will need to only a sample, not the entire population. Thereby, the researcher might divide this heterogeneous population into different stratum. But this time, okay, I forgot to inform one important step. In stratified random sampling technique, the samples are selected based on probability proportional to population size. We call it as PPPS, probability proportional to population size. That is, let me give you an example. Suppose, say, medical sciences, if I have, let us say, 2000 students, technical 6000 students, humanities 1000 students. So, altogether, n is equal to 9000. On sample size calculation adopted, but the method adopted to calculate the sample size, I got the sample size as 1500. Of course, I can choose 500 in each stratum, but here in this case it is right underrepresented, whereas here and here it is overrepresented. Particularly in the humanities, the population size is only 1000. If I'm choosing 500, every alternate may be selected, so therefore it is overrepresented. What I'm doing is, I'll divide this size of the population multiplied by sample size divided by population size. Maybe I'm getting around 333. This case, again, I'll get around 1000. And in this case, same technique, I'll be getting around 167. Altogether, n is equal to 1500, and this whole procedure we call it as PPPS. But in case of quota sampling, this is missing. So it is proportional to population size without assigning any probability we go for. So therefore, in quota sampling, we adopt this proportional to population size for allocating the sample size to the respective stratum. Right. Snowball technique is one of the commonly adopted technique when there is an unorganized sector particularly. So first we identify one sample and collect the data from that sample, get some link through that first sample to the other samples. So it continues in that way, which we call it as snowball technique. So I'll skip these things. Yes. Next is sample size calculation. Why do I need sample size? Professor TPM Pakala was mentioning about, say, student t-test, ANOVA, etc. I'll take an example to make you understand why I need sample size. Let me take the example of, say, gout. Gout is a disease of joint swelling. Particularly, most of the senior persons would be suffering from this kind of a condition called as gout. So, For the treatment of this gout, they use different medications. I mean, let me not go into that clinical trial example. But from this, what I am trying to measure is uric acid levels. Is a numerical value, quantitatively measured. So therefore, it is a numerical value. When it is numerical value, let me assume that this data follows normal distribution, because that is one of the assumptions we require for applying t-test. So I have calculated for two groups, let us say group 1, group 2, sample data. I have selected N1 and N2 as the sample sizes. So x bar 1, S1 square, x bar 2, S2 square. Now, from the study, I found that for the group 1, the sample mean was found to be 8.16. For this, I found it to be 7.11. Variances is 2.19, and here this side it is 1.93. Now, I don't go into more details on testing of hypothesis. My only intention is to make you understand the importance of sample size. If I have to apply t-test, let us say I've taken equal sample size in a clinical trial. Usually we take 1:1 ratio. So it is x bar 1 minus x bar 2 minus mu1 minus mu2 divided by square root of S1 square by N1 plus S2 square by N2. This is what we call it as standard error. And Professor was telling about always mean 1 need not be equal to mean 2, but for this example, I take it as mean 1 equal to mean 2. And in this case, I am taking mean 1 not equal to mean 2. This is my hypothesis. And you know what? Suppose first I take N1 is equal to 10 and N2 is equal to 10. If I substitute in the formula and simplify, first example, I get the value as 1.636. Second case, I'll take here, this is N1 is equal to N2, that is equal to 10. Second case, I'm taking N1 is equal to N2 is equal to 20. So 2.313 T3. In this case, I've taken N1 equals N2 equals N, that is 30, where I got the value as 2.831. Now, this is enough for my discussion. Based on the rejection criteria, maybe the first one is rejected. Sorry, first one is not rejected, not rejecting H0. I should refer to the degrees of freedom, find out what will happen to this. Most likely, this is rejected. So we are rejecting H0 in this case. This I need to check it. Now look at here. The same example with different sample sizes. In some cases, we are rejecting H0, and in some cases, we are not rejecting H0. So therefore, If you say that I'm restricting myself to 10 samples, there is a possibility, right, a true drug might be rejected. A true drug, effective drug may be rejected if the sample size is small. If the sample size is large, there are certain ethical issues. Why should unnecessarily be subjecting so many patients for investigation? It's a question of ethical. So therefore, neither we need a small sample nor a very big sample. What I need is an optimal sample size. So therefore, it is based on certain factors. So once again, I've taken here the observed data as truth plus bias plus random error. But what I need or required for calculation of sample size is the main research question. What is the outcome measure you are looking for? And statistical procedure. Statistical procedure, I mean, is it mean or proportion or variance or correlation? What is that you want to find out? Is statistical procedure. We also need statistical, of course, you forget about this. We need to know about statistical assumptions and study constraints. We require all these things when we want to calculate the sample size. Right? And also, it's important that whether your sample size calculation is for estimation purpose or for testing purpose, testing of hypothesis purpose. Sample size calculation for estimation purpose is different and testing purpose is different. This becomes only descriptive part of the study. This is descriptive. Estimation is descriptive. When it comes to testing, you need to have a comparative. In case of testing, I need to have a comparative group. Naturally, the sample size varies. And this alpha is another requirement which we use it in testing of hypothesis, which is called as probability of false positive rate. Otherwise, it is also called as probability of type 1 error. Moreover, the direction of the hypothesis also influences the sample size calculation. Meaning, like in case of alternative hypothesis, if I take mean 1 less than mean 2 or mean 1 greater than mean 2, sample size reduces. One direction. If I'm using the alternative hypothesis as mean 1 not equal to mean 2, the sample size increases. That's what I've said here. One-sided test requires smaller sample size, whereas the two-sided test requires larger sample size. Usually alpha, conventionally, we take it as 0.05, for which we have some standard values. In case, if you reduce this alpha to 0.01, then the sample size also increases. One more, we call it as power of the study, because beta is nothing but probability of false negative, otherwise probability of type 2 error. And 1 minus beta is very important in research because the power or power of the study is directly related to making your alternative hypothesis accepted. It increases the chances of accepting your alternative hypothesis. So, if you want your power to be 80% or 90%, accordingly, the sample size calculation also changes. If I'm looking at 90% power, definitely the sample size will be more than what is required for 80%. But remember, larger sample size, you should also consider those resources, money, manpower, material, and time. That is also a a point to be noted down if you're thinking in terms of increasing the sample size. So smaller difference, larger sample size are required. So this is based on the formula. This is we can say that this is this is called as Cochrane's formula. So here P is the proportion, Q is 1 minus P. This is desired precision. I've given here level of significance, this Z alpha by 2 at the level, specified level of alpha, we calculate this, we obtain this Z alpha by 2 value from the Z table, is a proportion or prevalence, and D is desired precision. We talk about desired precision. Okay. So some of these examples are taken from medical. I don't want to go into medical examples. I'll take up some examples which are general in nature. So therefore, now Cochrane formula is n equals Z alpha by 2 square PQ divided by D square, right, when this is population is infinite. We use this formula, and a main formula, this is for finite population where we take Z is equal to, it is nothing but capital N divided by 1 plus N into D square, where N is finite, known value, finite and known value. There is an alternate for this formula, that is N equals N equals, we have a very simple formula which is given in the form of, let us say, N, capital N, Z alpha by 2 square PQ divided by N minus 1, capital N minus 1, D square plus Z alpha by 2 square PQ. This can also be made use, right? And if you want to incorporate power into the calculation of sample size, then the formula is going to be Z alpha by 2 plus Z1 minus beta whole square, right, into PQ divided by D square. So these are some of the formulae, of course, based on, variance. Suppose the same formula based on variance, we have the formula for N Z alpha by 2 square S square divided by D square. This is for when you are estimating the mean. This is estimating proportion. But this is for estimating the mean. We make use of the sample variance. This sample variance data or population variance data will be taken from previous studies. Even p value also, the proportion, is generally taken from previous values. If not previous values, you need to conduct a pilot study. Whatever results we get from pilot study, we use it in the calculation of sample size. And here also, if it is based on variance, so it is Z alpha by 2 plus Z1 minus beta whole square S square divided by D square based on variance. Same thing, we have calculation of sample size based on correlation coefficient. Many statistical procedures are made use depending upon the topic. We can choose our formula for calculation of sample size. So time factor, I'll stop it here. So any questions, I'll take it up now. Please. Anyone has a question, I'll happy to answer. Yes, please. Anybody has a question?
Thank you, sir. Thank you, sir, for your enlightened presentation on the sampling. So there are some questions which we have received from the participants.
Please. I'll be happy to answer them.
Fine, sir. So the question you can also see on the screen, sir. First one is whether the denominator is proper in case of small sample for t-test.
No, I didn't get it.
Uh,
I didn't get the
whether
question. Yeah, whether denominator is proper in case of, what do you mean by proper? What do you mean by proper?
I think the
Or what you are
participants is
referring
asking
proper?
for the t-test analysis.
See, denominator should be optimal, I said. Neither small nor very large. Small sample size, what you are intended to prove is not possible to prove it. Large sample size, as said, for resource reasons and ethical reasons, we are not allowing for very large population, very large sample size. It is an optimal. I gave some examples. What will happen to the acceptance or rejection of null hypothesis when n is equal to 10, n1 is equal to n2 is equal to 10? What will happen in case of n1 is equal to n2 is equal to 20 or 30? So therefore, with the formula what I have given, if you adopt it, you can find out the optimal size based upon that formula P, Q, and D, as well as alpha and beta. What, depending upon the problem, depending upon the problem statement. Say if you are like for example, I had taken the example of, say, I gave an example based on estimating, right, the addiction to estimation of social media addiction by college students. How to calculate sample size for this? So in this case, what I'll do is, if I have to calculate the sample size for this kind of study, if I don't get any kind of a data from previous studies, I'll go by taking, let us say, P is equal to 0.5 as an assumed proportion. I'll go by assumed proportion as 0.5. Obviously, Q is equal to 1 minus P, which is also 0.5. And alpha I'm taking 0.05, implies I'm taking up 95% confidence level, and I look for D is equal to 10% desired precision. Desired precision. With this, when you apply the sample size calculation, simplification, it gives you around 96. And we also need to add 10% non-response error. Thereby, the net sample size is going to be around approximately 110. Okay? And There is one more background. If this is done in a small scale, 110 is fine. If the study is going to be done on a large scale in a community, we apply what is called as design effect. We use this design effect. Say, for example, I might use a design effect of 2, thereby n becomes 220. Depends upon the type of study which we are using. So this is how the sample size are calculated, but usually the p-value will be referred from previous studies. P-value or standard deviation or variance, we have to choose them from previous studies. If not available, try to get the data from pilot study. If you're not able to do even pilot study for various reasons, then you can use this assumed proportion. Yeah.
Thank you, sir.
Yeah.
The next question is, how does sample size selection differ in qualitative and quantitative empirical studies?
See, we know that quantitative method of studies requires this particular formulae. In case of qualitative research, do you need more samples? Basically, what is qualitative research? Qualitative research may be an opinion study. We use, say, for example, Delphi method for collection of data, focus group discussion, right? Or else sometimes people take the videos and pictures and analyze them. There are various ways of doing qualitative research, and there you need to look at the feasibility and fix the sample size. But definitely for quantitative method, we need to adopt this one of these methods for calculating the sample size.
Okay, thank you, sir. Thank you for the answering the questions of the participants.
Thank you,
Desai,
sir.
madam.
Yes. Thank you, sir, for your thought-provoking and inspiring words. Thank you once again, sir.
Thank you. Thank you very much.
It is now an honor to invite our principal, Dr. Y. Tammanna, sir, to deliver the presidential remark. Under his leadership, our institution has flourished, and we are very grateful for his continuous guidance and support. Over to you, sir. Sir, please.
Thank you, madam. Good afternoon, everyone present here. I understand that after a series of in-depth presentation and discussions, many of you might be feeling a bit exhausted. Let me to take a moment to appreciate our resource person. So I won't take much of your valuable time. Under IQAC initiative, the Department of Statistics, in collaboration with Karnataka State Statistics Association and also Alumni Association of our college, organized a one-day national level webinar on essential skills and sampling, key to success in statistics. Respected resource person, Professor TPM Pakala, Adjunct Professor, Mangalore University, Mangalore, distinguished resource person, Professor Gangaburaya Sarji, Professor Emeritus of Statistics and Research Head, Dayanand Sagar College of Dental Science, Bangalore, and my best friend, Dr. A.T. Srinivas, HOD of Statistics and convener of this webinar, and Dr. Bhakti Mahendrakar, IQAC Coordinator, Organizing Secretary, Mr. MP Myagedi and Ms. Kavita Ahmad, and Mr. Suleiman, my colleagues and research scholars and delegates from the different parts of this nation. It's my great honor to stand before you today as we are near to conclusion of this enlightening and thought-provoking national webinar. Our past sessions, we have engaged in meaningful discussions, explored new perspectives, and deepened our understanding of essential skills and sampling key to the success in statistics. At the heart of this intellectual exchange are our distinguished resource persons, whose insights, experts, and dedication have greatly enriched our discussions. Now, let me to express my heartfelt appreciation to them. At the very outset, I deem it's my pleasure to extend my warm and sincere thanks to Professor Gangaboraya sir and Dr. TPM Pakala sir. We have we have heard two learned speeches, one by Professor Gangaboraya and another by Professor TPM Pakala sir. So I will do it a little later. I would like to highlight few points from your speech, sir. Ensuring representativeness. Sampling techniques are designed to select a subset of individuals that accurately reflects the characteristics of overall population. This ensures that the inferences made from the sample can be generalized to the broader population, reducing biases that may result from our unrepresentative sample. And second point is that minimizing sampling error. Different sampling methods, for example, sample random and stratified cluster sample. These different sampling methods aim to reduce sampling variability. By choosing an appropriate method, statisticians can estimate and control for sampling error, so which is crucial for determining the precision of the estimates and constructing reliable confidence in intervals. Sir, your views on essential skills for this one successful career in statistics has provided us with valuable knowledge and fresh perspective. Your in-depth analysis and practical examples have broadened our understanding and inspired us to explore new solutions. And secondly, Professor Gangaboraya sir, uh, sir has rightly said that statistics is the backbone of decision making in every sphere, from public policy and healthcare to finance and research. The essential skills we cultivate in this discipline empower us to analyze and complex data, draw meaningful conclusions, and ultimately drive innovation and growth. At the heart of these skills is deep understanding of our sampling techniques, a fundamental tool that ensure our analysis are both representative and robust. Sir, your insight on uh, importance of sampling techniques in statistical inference have been both eye-opening and transformative. Your passion and commitment to this field have inspired us all. We are grateful for your wisdom and you have shared. So, lastly, but not least, I extend my gratitude to organizers, resource persons, and all participants who have made this program possible. Let us move forward together, strive for excellence in a very aspect of our institution. With these few words, I will stop it. And thanks for this opportunity. Thank you, one and all. Thank you,
Thank you,
I have a
sir.
word from my side. I have a word from my side. The
sir.
time is restrictive. Actually, the topic is vast and time is restrictive. I rush through because of the time factor. Otherwise, I wanted to go slowly by giving the examples.
No, sir,
Yes, sir.
your
Whatever.
presentation really I have enjoyed a lot. Very informative, very
Thank
informative,
you.
sir.
Thank you. Thank you very much. And I
Thank you,
thank
sir.
organizers as well as Dr. Srinivasa. And I should also thank one another person who brought me the link between you and I, that is Dr. Suresh from Bangalore University.
Yes,
Dr.
sir.
Suresh,
Yes, sir.
thank you
Yes,
very
sir.
much.
Thank you.
Yeah,
Thank
thank you, sir.
I
Uh,
have a class. I have to go now. Thank you once again.
sir, thank you. Thank you so much for sparing your valuable time with us. Really, I felt very happy, sir. And one more thing is that the similar cooperation we need, sir, in the days to come.
it. We'll definitely do it. We'll definitely do it. Not an issue.
Thank you, thank you, thank you,
Thank you.
sir.
Thank
Thank
you
you
very
so
much.
much. Yes,
Right.
thank you.
Sir, could you please wait for another 2 minutes because one of our faculty is going to propose oath of thanks. Sir, please.
Madam, I have a class. Students are waiting. You please propose it, but I have to go to the class. Sorry.
Yes,
Okay,
sir,
sir.
sir, sir, sir.
Thank you,
Thank
sir,
you, sir.
for your motivating and encouraging words,
Thank
sir.
you.
Thank you, sir.
Thank you.
Thank you.
Where Pakala, sir, Professor
So,
PS, TPS, Pakalam, sir.
he has muted his call, sir. He has muted his call.
Yeah, yeah.
Yeah.
Yes.
So, should we start the next, sir? Sir,
Huh.
because Pakran sir has muted his call.
Okay, you can start now.
So, as we draw this enlightening session to a close, I would like to invite Ms. Kavita Mutt, Faculty, Department of Statistics, to deliver the oath of thanks. Kavita, it's over to you, madam.
Madam, please.
Yes,
Uh-huh.
as we came to the conclusion of this enriching webinar, it is time to express our heartfelt gratitude. On behalf of the Department of Statistics, we extend our sincere thanks to our esteemed speakers, Professor T.P.M. Pakal sir and Dr. Gangaboraya sir, for your profound knowledge. Your insights have been invaluable. We are grateful to our principal, Dr. Y. Tammanna sir, president of this webinar, for your constant support, sir.
Thank you.
A deeply gratitude to our Dr. Bhakti Mahendrakar ma'am, IQAC coordinator. Thank you, ma'am. I would like to extend my heartfelt thanks to our convener, Dr. A.T. Srinivas sir, HOD of Statistics, for encouraging in all aspects and for their efforts in making this webinar success.
Thank you, madam.
I would like to thank Dr. Gani sir and Assistant Professor Mr. Manjunath Myagedi sir for their introductory speech. A special thanks to our Assistant Professor Srimati Husna Desai ma'am for hosting this webinar. And a
Thank you.
special thanks to our Assistant Professor Mr. Suleiman Hattarki sir for technical support. Last but not the least, we extend our heartfelt appreciation to all the participants, faculty members. Your enthusiasm and engagement have truly enriched this session. With this, we finally conclude our national webinar. We hope this session has been insightful and thought-provoking. Thank you all and have a great day ahead. Thank you.
Thank you, one and all. Thank you.
Thank you, madam. Thank you, sir. Thank you.
Thank you, Professor Srinivas, sir. Wonderful
Sir.
session. More participants were there. I think this is one of the best webinar what I have seen